Okay, so hello everyone. Good day. Thank you for joining this episode of our Tech Talk series. So for this session, we're gonna talk about infrastructure as code for developers and how easy it is for you to codify and automate your Exadata database service deployments using our brand new OCI Terraform Landing Zones for Exadata database service. And today, I'm very excited to introduce my co-host. So I have a co-host for today. She's also part of the product management team for database cloud services. So hi, Sheena. Thanks for joining.
Hi, Rio.
Hi. Okay. And for today, we're gonna cover this learning points. So we'll start with introducing you to the different OCI management interfaces, which is infra as code is also included as one of the options, and then we'll jump into the infrastructure as code and OCI strategy using Terraform, and then we'll introduce you to the landing zones. And then we'll talk about why did we develop the OCI landing zones for Exadata database service. We'll walk you through the different benefits of using the landing zones, as well as to cover the different use cases and scenarios where you can use these ready landing zones for Exadata database service, and then Sheena will walk us through a demo on how you can easily adopt this landing zone. Okay, so since in this session we'll be uh, mentioning about database cloud services, like how do we manage cloud database services. So I'll just do a quick run through. So Oracle offers a range of database services in Oracle Cloud. So in general, we try to bake them to by the scale and performance requirements for the system, and if the system will reside in either Oracle Public Cloud or in a customer data center. So in the Oracle Public Cloud, so we offer first the base database service. So this one runs both standard and enterprise edition Oracle database and allow you the ability to spin up a single instance or a two-node rack database deployment. And all this database cloud services runs the same database software as on-premise with a robust set of cloud automation tools. And then later on in the session, we'll be introducing you to what are those other OCI management interfaces. And then when you need more scale or performance, so you can choose our Exadata database service, which brings the Exadata platform to the public cloud on dedicated infrastructure, or you can also have your Exadata database service on an exascale infrastructure. Then both base database service and Exadata database service are co-managed services in which Oracle manages the infrastructure and you manage the customer VM hosting the database software. And all of the Oracle Database Cloud Services provides you with a robust set of cloud automation tools that you can use to perform VM and database lifecycle management tasks. Okay.
Yeah, and for those who want a fully managed database experience, you can choose the autonomous database that can run on shared or dedicated Exadata infrastructure.
Yeah. And then did you know that the Exadata database service, it provides you a choice of multiple deployment models to suit your business and workload requirements.
Yeah, one of the greatest differentiators of Exadata versus the other database platforms is the flexibility it provides in terms of deployment options. Like you can run it on premises with a traditional CapEx deployment model where you own and manage the complete system and have total flexibility as to how you will manage it. You can also run it in the cloud where Oracle manages the infrastructure. You have automation to simplify your management tasks, and you can leverage a pay for use subscription model that can dramatically reduce your costs. Now, Oracle offers Exadata in the public cloud with Exadata infrastructure. With Exadata Cloud at Customer, you can benefit from a cloud deployment model but keep all your data safely inside your own data center. Now, Exadata is also available with multi-cloud, where databases run on Exadata in Oracle Cloud and applications run in other clouds. Now, in this session, we'll be focusing mostly on the Exadata database service on dedicated infrastructure on OCI and on multi-cloud.
Okay. And then also for this session, so to make things more interesting, so we'll be sharing some cool did you know facts throughout the session. So these are trivia tidbits that will highlight surprising and useful aspects of Oracle Database Cloud Services that you might not be aware of. So stay tuned for some fun discoveries. So for our first did you know? So did you know that you can programmatically manage Oracle Database Cloud Services using powerful tools like REST APIs, SDKs in your favorite languages, and CLI scripting, and also infrastructure as code using Terraform or Ansible. And yes, so with Oracle Database Cloud Services, it gives you that flexibility on how you want to manage your environment. So for example, so if you want automation or integration with your existing tools, so you have those ready APIs available for almost all the management tasks.
That's right. And for developers, there are SDKs in popular programming languages, so you can decide and integrate database operations directly into your applications. If you prefer scripting, the CLI supports powerful automation. Plus, for those working with infrastructure as code, Oracle supports tools like Terraform and Ansible to manage and provision the resources efficiently.
Yeah, and then OCI provides you a wide choice of management interfaces that you can use with your database cloud services. I mean, in this session, we'll be showing specific to Exadata database service. So the easiest way, of course, is to use the web browser UI. So this allows you to use a browser to graphically configure and initiate your lifecycle operations. But if you prefer to do a more programmatic interface for things done repeatedly, such as if you want to provision a fleet of databases, or if you want to apply like updates or to patch databases. So anything that you can do from the UI, it can also be done with the corresponding OCI APIs.
Yeah, and all interfaces are also exposed via a CLI that can be used for scripting and for building custom tooling. And there's a SDK to integrate with common languages like Java, Python, Ruby, and Go. Now, if you prefer to manage your infrastructure as code, there's also Terraform and Ansible interface for you.
Okay, and that adopting infrastructure as code or the IAC, so it really transforms the way you manage cloud environment. So you can define your entire infrastructure from servers, databases, networks in code, just like how you would do it on your application.
Exactly. Like that means you can version control your infrastructure, automate deployments, and reproduce environments reliably every time. It's a huge step in efficiency and consistency because you're managing the cloud with the same practices and tools you already use for your code. So now let's start with the core concept behind what we are discussing today, infrastructure as code or IAC. Now, instead of provisioning infrastructure manually every time in the console, IAC lets you express that configuration in files. This means we can version it, review it, and share it, just like application code. So if your team needs to deploy the same environment multiple times, let's say in dev environment, test, UAT, prod, you can apply the exact same configuration with consistency and confidence.
Yep, and Sheena, I like this statement at the bottom. Like we're not really replacing the console, so like we're just offering them another interface, which is the infra as code.
Right.
Okay, and Did you know that Terraform is one of the most widely used infrastructure as code tools, allowing you to provision and manage cloud resources seamlessly through straightforward, declarative, and configuration files. So let me just walk you through quickly on why most of the users love to use Terraform. So first, it's cloud agnostic. So Terraform, you can it uses one consistent configuration language, which is the HCL, that works identically across different clouds like OCI, AWS, Azure, and Google Cloud. And it's a declarative. So meaning Terraform's declarative approach means you just need to specify the desired end state rather than doing the step by step procedures. And then it comes with a ready version control. So this provides a complete audit trail of infrastructure changes that helps you to enable rollbacks to previous states, and it has a concept of uh, Terraform plan and apply. So Terraform plan, it gives and generates you a detailed execution plan. So showing what exactly will change before any modifications occur. While the Terraform apply, so that's the one responsible for executing those changes with confirmation. And that Terraform is idempotent. So Terraform operations are idempotent, so meaning running the same configuration multiple times results in an identical infrastructure state. So, meaning the configuration drift is automatically detected and remediated, and that your failed operations can be safely retried. And Terraform gives you a modular approach. So Terraform's module system enables code reuse and encapsulation. So meaning your team can easily create standardized infrastructure components as modules with defined inputs and outputs based on your requirement, leading to a more consistent infrastructure patterns across all your products. And did you know that you can use infrastructure as code with Terraform's ready-made providers like OCI and resource definitions to seamlessly automate and manage OCI deployments, including Oracle database cloud services?
Yeah, and one of the great things about Terraform is its ready-made providers and resource definitions, which make it incredibly easy to automate the OCI deployments. Now, with Terraform, you can not only set up the Oracle Cloud resources, but also manage Oracle Database Cloud services, all through automation. This means less manual effort, more consistency, and much faster cloud deployments.
Okay, so for deploying, let's take an example. So specific to deploying Exadata database service on dedicated infrastructure. So you have all this ready OCI provider resources that you can use. So for spinning up an Exadata database service on dedicated infrastructure, so you need all these resources on the left. So starting from the Exadata cloud infrastructure. So the corresponding uh, OCI provider resource is the OCI database underscore Exadata infrastructure. So this one creates your cloud infrastructure. The database cloud VM cluster is the resources for you to create the Exadata VM cluster on your infrastructure. And that one will be requiring also the uh, network component, such as your client and backup subnet. And then the rest are the resources for creating your database. So you have your database DB home, which will create your database home, and then the database underscore database. So that will create the CDB, and then the database underscore pluggable database is the one responsible for creating your PDB. So where to start? So if you search on OCI Terraform provider, so it will redirect you to the your source of truth. So here, just go through the database resources, and then you'll see then look for the Exadata, I mean, to the cloud Exadata infrastructure. So this one for the infrastructure. This is for the cloud VM cluster, and then this is for the CDB, and then the one you also see one resource for creating your pluggable uh, database. Okay, and same thing. So as a developer, you can also use infrastructure as code to deploy resources across multi-cloud environments. So including Oracle Database Cloud Services, since both Oracle and our other hyperscaler partner offer a ready-to-use Terraform providers and resource definition. So let's just see some of the examples. So for the let's take for example the Oracle database at AWS. So this is how we structured the Terraform resources that you need for you to spin up an Exadata database service on dedicated infrastructure. So for Oracle database at AWS, um, your cloud infrastructure and cloud VM cluster will be part of the AWS provider, and then all the database resources will be from the OCI provider. So imagine this on your Terraform configuration on your main.tf, you should have you should be calling the two providers, AWS for provisioning the infrastructure and VM cluster, and then OCI for the database. And then we will also be sharing you the links to the documentation, like for this one for the AWS. So you'll see that's also available here for you to use. So you have a resource for spinning up the Exadata cloud infrastructure. So if you look into uh, their documentation. So you also have resources for creating the cloud VM cluster, creating a autonomous cloud VM cluster, resources for spinning up your ODB network, and also your ODB network peering connection. And then for the OCI side, so after you have provisioned your uh, cloud infrastructure, Exadata cloud infrastructure and VM cluster, then next is calling the resources from the OCI provider to provision your database home, uh, CDB, and PDB. And then for Oracle database at Google, so at GCP, so same thing. Your cloud infrastructure and VM cluster, it's part of the Google Cloud Terraform resource. So there's also a section here where you can see all the Oracle database related resources. So same as what you've seen in from the AWS. So there's also resources for creating Cloud VM cluster, autonomous database. There's also resources for an ODB network and an ODB subnet. Okay. And then for the database at Azure, so same thing. So you have the ready Azure resource manager, I mean Azure RM resource for spinning up a cloud infrastructure VM cluster, and then all the database related will be coming from the OCI side. And then when you run the Terraform, so let's say for example this Oracle database at Azure, when you put all these resources in your Terraform script, so it will start with provisioning all the Azure required resources, such as your resource group, and then it will call in the resources to provision your Exadata cloud infrastructure, and then your virtual network, which are the required VNets. It also comes with the delegated subnet, which will be attached and will be used by your VM cluster that will be running on that cloud infrastructure that you just provisioned. And then after you've provisioned all the required Azure resources for Exadata database service, and then on your Terraform, it will just be calling the OCI provider to spin up the database home, the CDB, and the PDB. Okay. Okay. And did you know that you can use Terraform in OCI by just writing simple configuration files to define your cloud resources, then deploying and managing them automatically with just few CLI commands. So in OCI, so this is how you uh, configure Terraform. So we've listed here the steps. So first is for you to install the Terraform and configure the Terraform provider. So we will also be sharing the links to the documentation. So first is to install the OCI Terraform provider. Then you need to configure the provider. So you need to define your credentials. So there's a step here in which you will generate the API key for authentication. And then next is for you to describe the infrastructure that you are building. So this part, this one will be the part where you create your script. So on your main.tf, you just need to put what resources do you want to use. Like from our example a while ago. So let's say for the OCI deployment. So you need to have all of this on your Terraform script and then run it on your OCI. Now, if you don't want to do that approach, so did you know that there's also a framework called OCI Landing Zones? So that lets you set up standardized cloud environments using infra as code. So before we introduce landing zones, so teams who wanted to deploy Exadata database service using Terraform would create their own modules. So as what I've shown you a while ago. So you need all those resources to be on a script and the provider. So this works really well in cases where you want to manage every detail of your networking cluster setup, DB homes, CDBs, and PDBs. And if you want to have a full control over how the modules are structured, so especially if you're dealing with some customizable parameters that you wanted to include on your Terraform script.
Right. And that approach is still there. We can still do that. It continues to be very valid and very powerful. The only trade off is that it usually requires more setup and a deeper knowledge of Exadata resource relationships. So it's ideal for advanced teams that want to design their own blueprint instead of using a shared one. A landing zone is simply a collection of Terraform modules arranged in a reusable pattern. So instead of starting with a blank Terraform configuration, you start with a pre structured layout that already understands how the Exadata components relate to each other.
So, Sheena, this landing zones, these are ready modules and templates that they can just use, right? And run it.
Right.
Okay.
Yeah,
So,
it deploys the exact same Exadata resources as you would through the console or through custom Terraform. It just expresses those deployments in a standardized and parameter driven form that many teams can share across various environments.
mhm. Okay, and so why we have developed this OCI landing zone for Exadata database service. So the idea of landing zone is that landing zones are helpful when multiple teams try to deploy Exadata database service using infra as a code. So if you want to have like a consistent starting point, so meaning instead of building your Terraform script from scratch, so you can just take out and download this ready OCI landing zones for Exadata database service, which has some sample ready modules and Terraform templates that you can use for spinning up Exadata database service using different architectural patterns. Like it could be for multiple environments, right, Sheena?
Exactly, right. Like if you want to repeat the deployments across multiple environments like dev, test, UAT, prod, or even across multiple business units, in that case, it's very useful. Like if everyone is using the same building blocks with the same variable inputs and the same predictable outcomes. So this is really about standardization and reusability. Like here are some of the deployment patterns that we are supporting out of the box. So you can do a quick start, single instance deployment, or you can deploy Oracle Exadata database service in multiple environments. You can deploy multiple clusters in the same VN but in different subnets. You can also deploy multiple clusters on different VCNs or add an additional home to an existing VM cluster.
Yep. And Sheena, these are just some of the starting patterns that
Yeah,
they can use. And again, it's not a closed box, so meaning they can tailor it based on their requirements. So like for this starting patterns, like if you need to spin up Exadata database service for your multiple environments like dev, test, UAT, so you can use this ready Terraform landing zones. So if you're also working on, let's say, on a test project or a POC, so you can use this OCI landing zones for you to quickly spin up your Exadata database service with databases. So like here, I can see here that they can even start with multiple VM clusters. So with different scenarios, it could be you're running on the same VCN or it could be on a different network. So we have all those covered on this starting patterns. And also if you wanted to like have your own modules just for creating the database, because some might prefer uh because what we're showing here is a sample, like an end-to-end stack from infrastructure up to VM cluster, DB home, CDB, PDB. But the good thing with the landing zones, they can easily tailor it. Like I can just get the module that I want. So for example, I have a requirement just for me to spin up multiple databases. So I can just get the modules for creating DB homes, CDB, and PDBs, and then I can just fire it as many as I want. Right, Gina?
right.
Yeah. Okay. So here is the OCI landing zone for Exadata database service. So again, this landing zone, these are ready modules and templates that you can use. Like so, these are ready scripts that you can adapt. And then this includes the resources from infrastructure, VM cluster, DB home, CDB, and PDB. So we even uh, prepared like an example folder there where you can see all those starting patterns, and then you can just quickly pick and choose what do you want, right?
All
So
right. Right.
in so we uploaded this on Oracle GitHub. So so when you click on the link, so you'll see this. So this is the OCI modules for Exadata database service. So, Sheena, do you want to take them through this?
Sure. Is my screen visible clear?
Yep. So I see that it's visible. They just need to click on the Sheena screen.
All right. So this is the Terraform OCI module that we have for Exadata. Now, when you go to the GitHub, you should be able to see the README if you scroll down. And then we have a few prerequisites that you can start with. So you basically just need to make sure that you have the required IAM policies, you need to create the RSC keys for authentication, and you need to have your VCNs and subnets set up for the Exadata that you're going to be using. Now, for using this, you can also use your OCI core landing zone, which is another landing zone that can set up the VCNs and subnets for you before you use your landing zone for Exadata. Now, once you're done with the prerequisites, you can basically just clone your code for the existing landing zone modules. Just copy the GitHub clone and then clone it into your VS Code. Here, I've already cloned all of it for you. And then you should be able to see this code structure out here. So we have a bunch of examples here. Like you can start with a quick start deployment for deploying, which would deploy your Exadata infrastructure, VM cluster, a DB home, database, and a PDB. You can also deploy multiple environments with multiple VM clusters in the same VCN, Or you can also deploy multiple environments with multiple VM clusters in different VCNs with DB Home, CDB, and PDB. We can also do additional VM clusters with multiple DB Home, CDB, and PDB, and additional DB homes with multiple CDB and PDB. Now, just to give you an idea of how to run this, the script basically starts from the main.tf, wherein we specify what all we are going to be deploying as part of this deployment. So this one, it does the infrastructure, VM cluster, and it also does the PDB, CDB, and the DB home. Now, these configurations are specified in a file input auto tfvars. Now, before you do all of this, it is good to just, go to the README for this and see how to run it. So you basically just go to the README, you rename the input auto tfvars template to the auto tfvars, and then run the Terraform init, Terraform plan, and Terraform apply. So just to go here, this is my input auto tfvars file that I was talking about. Herein, we specify our tenancy connectivity variables. So you just replace these with your tenancy, which I've already done here. You just enter your compartment ID, your subnet IDs, and network security groups, the OSIDs for all of these things. And then we specify so most of these are already pre-configured. If you need to change anything for your own deployments, you can specify the configurations here for infrastructures, for VM clusters that we wish to create, for the cloud DB home configurations, for database configurations, and for the pluggable database configurations. Once you've specified these, we simply just go to the folder where we have this file. Let's say I'm in the quick start folder right now. So I can simply do a Terraform init to first initialize the Terraform. Then I do a Terraform plan. Now, when I do the Terraform plan, it tells me what exactly it is going to create in my OCI. So it gives me this plan. It is going to create one Exadata infrastructure with these parameters. It is going to create one cloud VM cluster with these specific parameters, one container database with the specified parameters, one DB home with the specified parameters, and one pluggable database. Once I make sure that all of these are correct, I can just go ahead and do a Terraform apply. So once I do a Terraform apply, I can go and check in my OCI console if these things have been created or not. Usually the infrastructure takes about 40 minutes, and then the whole thing usually takes about 60 to 90 minutes to complete. So here you can see that this infrastructure has been created. If we go to the VM clusters, we can see its VM cluster being created, the database home, and the databases inside it, and the pluggable database inside it.
Yeah. And then Sheena, when you go back to that quick start uh on your code. So the quick start it creates the an end-to-end stack, right? From infrastructure, VM cluster, and DB home, CDB, and PDB.
Right.
And also, if, for example, I have already created my cloud infrastructure and VM cluster. What I want is for me to create multiple DB homes with multiple CDBs and PDBs on it. In OCI landing zones, do we have that kind of a sample?
Right. So if you go here, you're saying that we already have an infrastructure as well as a VM cluster. Now I just want to create additional DB homes with multiple CDB and PDB. So you would go to the first example. You would simply go to this folder, update your rename your template to input auto TFORs, like basically just remove the template from here and then make sure that all of the configurations here are correct. Now, what you do is, since we want multiple DB homes, here we have one DB home. Similarly, we can specify more DB homes. Let's say we have this one CDB that we've specified here. We can also specify another CDB, just
Okay.
like that. So in that way, it's going to create multiple CDBs as part of that one DB home. Similarly, we have this one PDB and we have another PDB.
Yeah. So for this example, they can easily tailor it based on what they want to create. So let's say this one shows like it creating two CDBs with two PDBs on each. But if I
Yes.
want to like create like five CDBs, I can just copy
Add
and
more CDBs there.
yeah. So it's easy and it's customizable,
Yes.
and they can also have a look on the different examples that we have developed. Like I
Yes.
see here, there's also an example on creating an additional VM
VM
cluster.
cluster. So here what we do is we already have an infrastructure, and after creating the infrastructure, we just create an additional VM cluster on the already created infrastructure.
Yeah, and this will help if they wanted to build like a multiple environments with the network isolation. Like I see here, there's even an example on creating an addition, I mean, multiple VM cluster on the same VCN or even creating a VM cluster on a different VCN.
Right. And in those cases, what we do is when we go to the template and rename our template, once we rename the template, you should be able to see all the places where we can update the. So let's say here I want to create on my already existing um, infrastructure. So what I'm going to do is in my VM cluster itself, I'm going to specify which Exadata infrastructure I want to create my cluster on. So what that is going to do is when I check which infrastructure that is, it should, this is the name. So whatever infrastructure I created here, it is just going to use the same infrastructure. I could also directly specify the OSID in my VM cluster configuration. So in my VM cluster configuration, if I want this VM cluster to be created on a specific uh, infrastructure that's already existing, I can just specify the OSID of that infrastructure here and it would get created on that one.
Yeah, and also for the landing zone, we highly suggest to in especially in the input file. So we've even added their description for the what are those required parameters and what are those optional parameters. So if you look into the input file and let's say you need more or other parameters that you want to include on your Terraform script, then they can also uh, check it on the documentation that we have shown a while ago, right?
Right, which is this documentation that Leo just showed. So
That
you
that
can
will be there.
basically just go to whichever resource you want to add. If there are other parameters that maybe, let's say, we have not added some specific parameter, let's say cluster placement group ID in the existing example, then you can just add that parameter and use it. So basically, this is not a closed box. These are customizable frameworks that can be used.
Yeah. And then this landing zones, of course, the most important question. So this one, they can use it for free, right?
Yes.
Yeah. So this are uh ready scripts that our team have developed that our customer can use for managing Exadata database service on dedicated infrastructure. And also if they're working with multi-cloud environments. So a while ago, I've shown you that for creating the database, since it's part of the OCI, so meaning they can even check and get those modules from our landing zones, starting from DB Home to PDB, so they can also use it on their multi-cloud deployments.
Right. So just like we have the Exadata modules here, if you go to the OCI landing zones and go to repositories, when you search Exadata, you should be able to find the Exadata module for OCI as well as the Exadata module for Azure.
Yeah.
You can also use this one just
Yep.
out of the box.
And then if they if you type in multi-cloud from the search bar, it will also show those landing zones that we have for the other hyperscaler. Like we have landing zone for Oracle database at AWS, Oracle database at Azure, and Oracle database at GCP. Yep. Okay.
Right.
Let me just quickly share. Okay, so yeah, I think that that wraps up our demo for today. So if there are any questions or clarifications, or if you are interested on how to use the landing zones, we'll also be sharing this slides and all the links to our resources hub. So we have this public Slack workspace. So it's Exadata dash database dash service. This is where we publish all of the get started guides, how to demos, and then we also be uploading there the replays of our tech talk, like the replay of this tech talk episode. So how to join? This is the join link. You just need to click on this join link or just scan the this QR code, and after that you need to log in on your email account for Slack, and then check your email, set up your 2FA, and that's it. Welcome to our Slack workspace. So yep, are there any
Yes. So there's one question. Is there a live labs on this?
oh yeah, for the live labs, in the meantime, it's not live yet, but Sheena and I we're gonna publish that live labs soon. But if you want to use the landing zones, you can use it, you can just use it from the Oracle GitHub. You can refer to the README file there. So I think it's a comprehensive Sheena, right? Like we put all the instructions there. But yeah, definitely we will be publishing a live lab for this one. So we'll update you through our public Slack channel.
All
Okay.
right. So
And yeah, I think that brings our my tech talk with Gina to an end. And yeah, thanks everyone for joining, and stay tuned on our Slack channel for the recording of this session. Thanks everyone. Have a great day. Bye.
thank you, everyone. Bye bye.